So I will try to do the customer lifetime value calculation here, maybe in a slightly different way from what I've used in class so far, but let's just see here. You can use either way as long as you do it correctly. Okay, this is an extract of the top TOEIC exam that we worked with, and this is a crucial page 257 from the Kaplan book with a mathematic formula and explanations here. To begin with, there are at least two pieces of information I have to make readable to Excel, and one is retention rate, and in this case it is 80%, and you don't have to write that, but I just write it to emphasize it. This is year on year. So if we had 100% of the customers this year, we'll have 80% next year and 80% again of that in the third year. We have calculation rate. Sometimes they call it cost of capital or discount rate or something else. Here they call it calculation rate. I should do that correctly. Calculation rate is 6%, also called cost of capital. Well, that's the most likely other word you would find. Calculation interest, maybe. Okay, so then if we get it, I will just make this a little bit smaller so we can hopefully fit it all in. Okay, so one thing here is to have in mind how many years are we making the analysis for. So this is year. That's actually what they call T in the mathematical expression up to the top right. The year, and as you did in investment analysis when you had that in the AP program, you would have 0 for the year that you make the investment, and then you will start actually making money and doing normal business, doing operations in year 1. So we go from 1, and in this case, so when they say 5 years, they means 1 to 5, not. In other words, 0 is not included in that number of years. So this is 1 year to make the investment, 5 to hopefully have the customer. So that's the years, and I will skip a few columns, and then basically it's about 3 things. We could have, we'll have the cash flow. This is like the investment theory. Some money is going in or some money is going out of our company each year here. We have a cash flow. I could say, this is different from what you've seen before, I could say probability. How likely is it that this will occur? And then I should have, I have the issue that that 1 krona or 1 euro in year 5 is not worth so much to us as 1 in year 0. So if it's in year 5, we multiply it with a certain number to find the equivalent value up here in year 0. And as we have seen in class, this factor we have to multiply by, I usually call it discount factor. Maybe there are other words for that as well. So this is basically the things we should work with. And then, of course, how we get to a cash flow, you can need more or less columns to find out about that. I will say in this case they have up here margin, revenue less cost for the customer in year T. So I will use that word here. This is margin M, and it could be different in the years here. Whoa, and I will just make this a little wider. And then cost, any additional cost. So for instance, the cost up here could be the cost of goods, and this could be some additional marketing expenses and other things. But sometimes you also just get like a total result of the M minus C. Then you have the net margin, you might call it. So, but okay, here we'll say, I'll call it additional cost. Oh, something went wrong. I will have to fix that. C for the year T. I additional cost. Yeah, so we could say, they tell us here, we could say it's all in 1,000 kroner, all in 1,000 DKK. And, okay, so, can you still fit in? Yeah, maybe, I can squeeze this a little bit. So, here we have margin. So this is the margin they're making. Yeah. The important thing here is what you get out of M minus C in the end. The cash flow is actually generating each year. But if we stick to this, we could say that they have 2,500, 2.5 million as a kind of gross margin. No, sorry, actually here's the revenue. Yes, okay, I put just here and then I put all the costs together here. Then you can say, then it's not really a margin, then it's a revenue. But the really important thing is what you get in the next column about the cash flow. So, as long as you don't misunderstand yourself, it will be okay. The point here is they make 200,000 of kroner each year, as long as they have this customer. So I will take this data and I will take it because it's repeated identical for all 5 years. The short story is that they make 200 on this customer each year. And then they have what you would have called an investment earlier, but now they call it initial acquisition cost. But in your investment theory classes, that was the investment made. And here they say 600. And this is money we splash out from our company, so we put it as minus 600. I have shown it in some separate columns to you before, but this is maybe more elegant to have it in a separate column, but now I'll try to make the compact version today. Okay, and let us just see here. I think I'll do this first. So, this is a formula from your investment theory. Up here you can see it's under this, how do you call this, in the bottom of in the denominator is called in English, so bottom of this fraction here. So it's 1 plus the interest rate to the power of t. And if you go back to your math, if you want to put it up here just to multiply with it, you can do that. Then you just have to change this to minus t instead of t. And actually that's what I do here. Say 1 plus the interest rate. Some dollar signs. I need one for 14. Can you have one? This is okay as well, but I just prefer this. And to the power of minus the year. And this gives us 1. And I think it'll be neat with some decimals. So let's see this. And I'll pull it down. Whoop. We should at least expect that it's falling, and that seems to be right. So I could make a check here from the last one. 1 plus the interest rate to the power of minus t that we have over here. So if you get 1 krone in year 5, you must multiply it with approximately 0.75 to get to the value in the money of the first year, of year 0. So, and then we have the probability. Well, yeah. So actually, if I just make a little detour and say the way you normally did investment calculations in your basic program, that would actually just be like saying you have 100% each year. I do that all the way, and then I'll change it later. If there wasn't any risk that you would lose a customer, it would look like this. You invest 600, and then you get 200 out of it each year. This is not the final solution, but it's just a step on the way. Then you have to multiply all these 3 together, the 3 columns here. So this is, I could call this present value of, something happened here, of expected cash flow. Whoa, this is going to be a problem. Oh, it needs a white column. Okay, so that's basically multiplying these three together. This and that and that. Yeah. Make the same calculation for the next years. I want to have 2 decimals, for instance. And now I have this, and I can add them together. I can add them together here. It's the sum of all these numbers. And if you had your normal investment theory earlier, you call it net present value, would be the term in normal investment theory. So here you would get richer by 242 if you make this investment, so it's a good idea to make it. Basically the question is, you compare this to 0, and if it's a positive number, then you would say the investment is profitable or recommendable or whatever you might call it. But there is one big thing I have not done in the right way so far. This is, as you saw in investment theory, there you didn't consider the probability that some things would happen. But here is an important part of the story. So you think, okay, there's 100%, if you decide to go for that customer, there's a one you have decided to invest in getting onboarding them. So there's a 100% probability that you will have to spend this money. And you also assume that in the first year of doing business, you will have the customer. You just made a contract with them. So you'll get 200 out of that. But what is different here is that there is some risk in each of the following year that you lose the customer. So there's not 100% probability that you still have them. Boop. So I can do this in different ways, but today I think I will choose another approach that I've done sometimes in the classes. So I could say, yes, well, here I can basically say, well, there's 80%, in the second year, there's 80% chance I still have the customer. That's simply the retention rate. And then comes the next story here. Okay, if there was 80% chance I had the customer in that year, out of those 80% of the 80% is the combined probability I still have the customer in the following year. So I will multiply that with this, and I will pull this formula down. So I will want to freeze the 13, have a dollar sign before 13 here. So there's altogether there's a 64% probability I will have the customer in the third year. It goes on in the following years here, and yeah, so I go down here. This formula can be done in a very different way, and I've done that in some of the classes. So, but either of them is okay. You can also use this one, but it's not so close to what they did here. This is more like what I did in the classes. So this is maybe a more simple approach. So now we get the result, the same thing we got in class. Net present value is now lower, and actually I just choose a net present value because that was a normal investment term word. What we call it here is CLV. So now I call it CLV instead. So the conclusion is, it is not profitable. And I can put it here, CLV is negative. Not profitable. And then, if you actually go back to the question, I always recommend you read it in the end as well. Based on the above information, you have to calculate whether they're profitable. Would you recommend to go ahead with investment? And I say, no, not profitable. This will make it a little bit more elaborate in your exam. Discuss briefly where there are other circumstances that you would take into consideration in your recommendation. Well, of course, there could be things like, if you think it has like, it increases your brand value to have this customer. If there's some prestige attached to this customer, that could be one thing that's not reflected in our numbers, or if they can help you in some other way, you can get other customers based on that customer, or that could be one consideration. so they could help you with relevant work. You will get inspired from working with this customer. There can be a lot of things, but the most basic thing here that you could impress your teacher by doing is that when you make the conclusion this customer is not profitable, you could well, so basically what comes from now on is something extra compared to the assignment. The basic solution we have here visible on the screen. But again, you can say, okay, if something changed here, how much should something change in order to make this profitable? And a very simple thing, you could try to put 85% here, and you say it goes from minus to plus, and then you could say it's maybe about 82%. Ah, yeah, it's this. It's somewhere about a little less than 82%. If you can improve the retention rate to that level, then you can become profitable. I just take Control Z. So now I'm back. And you could of course also do changes. You could do sensibility analysis on this. If we could reduce this cost a little, we can see if we can reduce this cost just by 20. We could add the 20 here. This will be minus 580. This will be 20 higher, so it will be a very small plus. And we can make all these. We can make sensitivity analysis on basically on all the informations they have given us. Let's just take the more fancy Excel version about this. If you don't want to do this by trial and error, let us do what we've done in class sometimes. I would take data, what if analysis, goal seek, it's målsøgning in Danish. I would say the CLV is what I'm really focusing on, to the value of 0 by changing this cell and see if that works. Yeah, it does. I can say okay. It is not, it tries to format it without decimals. It's a little bit less than 82%. But so here you can write some interesting comment about this, that if retention rate could be improved to 82%, then it would become profitable. So I'll just put this one back here, and I will end this video. So I hope you enjoyed it. Yeah, I will put the video link address in here somewhere. Okay, bye bye.